This is video 4, we are working on rational exponents, exponents that are fractions, and how that relates to roots. And now we're going to do some algebra today. When I last saw you worked with numbers. So if we go to our class notes, and if you look, I want to relate this to what we've already learned. A lot of what we're doing in chapter 15 is review of what we've already learned about exponents from chapter 12. It just may look different now because the exponents are fractions. So let's go to the board and let's talk about some concepts. If you recall from chapter 12, if I asked you to multiply x squared times x cubed, by now none of you have a problem. You know the rule: to multiply the same variable, you add exponents. And this would be x to the 5th. So now, in this chapter, when I give you this, you should not be afraid. This is multiplying. These are the same variable. The rule is the rule. When you multiply letters, you add exponents. So what that the exponents are fractions? We know how to do that. So all I'm trying to show you is if I have rational exponents, yes, you could still follow the rules of exponents we learned in the previous chapters. When you multiply variables, you add exponents. 1/2 plus 3/2 can be added because that makes 4/2, and then 4/2 will reduce to x squared. So it's important to understand that even though these exponents are fractions, they still follow the rules of exponents. Multiplying variables means to add exponents. So now if you look here, if I have x to the 1/2 times x to the 5/3, I'm asking you to multiply letters, x's. To multiply variables, what do you do with the exponents? You add them. The problem now is to add 1/2 and 5/3. Uh-oh, what do you need? You need a common denominator. What's the common denominator of 2 and 3? You are correct, it's 6. The rules we learned is if you change the denominator, you've got to change the numerator. How does a 2 become a 6? We multiply by 3, so our new numerator is 3. How does a 3 become a 6? You multiply by 2, so 5 times 2 is 10. So x to the 3/6 and x to the 10/6 would be x to the 13/6. So it's very important you pay close attention to what you're doing. I'm not asking you to multiply fractions here. I'm asking you to multiply letters, variables. And to multiply variables, you learn to add exponents. Just the opposite. If I ask you to divide from the beginning of the semester, x cubed divided by x, we've learned. When you divide, you subtract exponents. 3 minus 1 is 2. So who cares if now the exponents are fractions? If I'm asking you to do division of variables, the rule is the rule is the rule. When you divide, you subtract exponents. So this would be 3/4 minus 1/4. And we can subtract that. That'll make 2/4. But as we all know, what is 2/4 reduced to? 1/2. So this answer would be x to the 1/2. Our last example, I have x to the 1/3 divided by x to the 1/6. Yes, I'm asking you to divide. I'm asking you to divide variables, letter x's. The rule is when you divide, what do you do with the exponents? You subtract them. So I want to do 1/3 minus 1/6. But wait a minute. You know to subtract, you need a common denominator, which is 6. 1/3, you have to multiply by 2 to make 6. So that'd be 2/6. This stayed the same. So 2/6 minus 1/6 is 1/6. So pay very close attention. Yes, what we learned the previous lesson was when you're working with rational exponents and the bases are numbers, yes, you change them into roots to figure out what the answer is. But now we're working with rational exponents and our bases are variables. To do this is just following the rules we already learned in chapter 12. Multiplying variables means to add exponents. Dividing variables means subtract exponents. Whether the exponents are whole numbers or fractions, the rules stay the same. Thank you.